In the cosmic dawn, a colossal tear birthed the galaxies, stars, and the very essence of existence. From that celestial explosion, life's tapestry unfolded, threading through the universe's grand design. Embrace the mystery as the echo of the Big Bang still reverberates in every corner of our cosmic home. For centuries, scientists have been trying to find out the secrets of the universe. How is it created? Is it infinite? If not, where is its border? At first, a theory was proposed by Richard Tolman in the 1930s, which consisted of the universe being part of a cycle where it was born, lived, died, and then was born again, where each cycle started a new universe. However, 18 years later, the three scientists Herman Bondi, Thomas Gold, and Fred Hoyle came to the conclusion that the universe didn't have a beginning or end. All of these theories aided the making of the Big Bang Theory, as it did not arise from a single discovery. In the journey to uncover the universe's secrets, scientists explored different ideas about how it all began. Back in the 1930s, Richard Tolman suggested the universe might go through cycles of birth and rebirth. However, things took a turn when Georges Lemaitre proposed the idea of an expanding universe, setting the stage for the Big Bang Theory. Then, in 1965, Arno Penzias and Robert Wilson found important evidence, cosmic microwave background radiation, which supported the thought of a big explosive event. It wasn't just one breakthrough, but a mix of these ideas that led to the widely accepted Big Bang Theory. Now, let's seamlessly transition into the timeline that solidified the Big Bang Theory. From its conceptual roots to widespread acceptance, it's a captivating journey through cosmic revelations. First of all, the Big Bang was not an explosion. It was all space, stretching everywhere all at once. It started very small and quickly expanded to the size of a football. For your information, the universe does not have any borders. There is therefore no outside the universe because the universe is all there is. In this hot, dense environment, energy manifested itself into particles that only existed for the smallest glimpses of time. From gluons, pairs of quarks were created, which destroyed one another. When something is destroyed, it creates energy. Therefore, quarks destroying each other created an infinite amount of energy. Instead of one massive ultimate force in the universe, there were several refined versions of it, acting under different rules. By now, the universe has stretched to 1 billion kilometers in diameter, which leads to a decrease in temperature. The cycle of quarks being born and turning back to energy suddenly stops. From now on, we work with what we have. Quarks begin forming new particles, hadrons, like protons and neutrons. There are many combinations of quarks that can form all sorts of hadrons, but only a few are reasonably stable for any length of time. Now, please take a moment to appreciate that by now, only 1 second has passed since the beginning of everything. The universe, that has now grown to 100 billion kilometers, is now cold enough to allow most neutrons to decay into protons and form the first atom, hydrogen. Imagine the universe being an extremely hot soup, 10 billion degrees Celsius, filled with countless particles and energy. Over the next few minutes, things cooled and settled down very fast. Atoms formed out of hadrons and electrons, making for a stable and electrically neutral environment. Some call this period the Dark Age because there were no stars and the hydrogen gas didn't allow visible light to move around. But what's the point of light if there isn't anything alive yet that could have eyes? Finally, there was light. When the hydrogen gas clumped together after millions of years and gravity put it under great pressure, stars and galaxies began to form. Their radiation dissolved the stable hydrogen gas into a plasma that still permeated the universe today and allows visible light to pass. Okay, but what about the part that we didn't talk about? What happened right at the beginning? This part can be defined as the Big Bang. We don't know at all what happened here. At this point, our tools break down, natural laws stop making sense, time itself becomes unstable. To understand what happened here, we need a theory that unifies Einstein's relativity and quantum mechanics, something countless scientists are working on right now. But this leaves us with a lot of questions. Were there universes before our own? Is this the first and only universe? What started the Big Bang, or did it just occur naturally based on laws we don't understand yet? We don't know, and maybe we never will. But what we do know is that the universe as we know it started here and gave birth to particles, galaxies, stars, the Earth, and you. Since we ourselves are made of dead stars, we are not separated from the universe, we are part of it. You could even say that we are the universe's way of experiencing itself. So let's keep on experiencing it until there are no more questions to ask.